They drilled into a sealed vault that had been shut for 40 years.
The scans didn't match. The vault had expanded, and something inside was
This is what happened.
The vault had been sealed beneath reinforced concrete for over 4 decades. No recorded entry, no maintenance, no reason to reopen it. Until now. On this channel, we investigate sealed and abandoned underground locations where researchers discovered something unexpected. This is one of those stories. The facility was built in 1979, deep beneath what is now an industrial park on the outskirts of a mid-sized European city. Its purpose was straightforward: long-term storage of low-level radiological instruments used in medical calibration research during the Cold War era. When the program was decommissioned in 1982, the vault was emptied according to protocol. All materials were logged, removed, and transferred to authorized disposal sites. Then the entrance was filled with reinforced concrete, 3 meters deep. The records were filed. The site was forgotten. For decades, nothing disturbed it. The land above changed hands twice. The industrial park expanded. New buildings rose, but the vault remained undisturbed, a relic buried under layers of bureaucracy and time. Then, in late 2024, a geotechnical survey was commissioned ahead of a planned metro expansion. Ground-penetrating radar swept the area, and something appeared on the scan that didn't match the archived blueprints. The void was there, as expected. But the cavity's dimensions were off. The original vault measured 4 meters by 6 meters, with a ceiling height of 2.4 meters. The radar showed a space nearly 8 meters wide. At first, engineers assumed it was a scanning error. Concrete density can create false echoes. Rebar grids sometimes distort the return signal, but 3 successive scans confirmed it. The underground void had expanded. A decision was made to drill a narrow exploratory borehole. Standard procedure, 6 centimeters in diameter. Just enough to lower a fiber optic camera and take air samples. The drill crew arrived on a gray morning in March. They positioned the rig directly above the vault's estimated center and began. The bit cut through soil easily. Then it hit the concrete cap. Progress slowed, but the drill pushed through. At 2.7 meters depth, the bit broke into open space, and immediately, the drill lurched. The operator felt it first. A sudden loss of resistance, but not clean. Something pushed back, not solid, not liquid. Pressure. Air venting up through the borehole, sharp and cold, carrying a smell like wet stone and rust. The crew stopped. They lowered a thermal probe. The ambient temperature inside the vault was 11 degrees Celsius. The soil around it measured 16. The vault was colder than it should have been. Colder than the earth around it. Next, they sent down the camera. The feed was dark at first, just the narrow beam of the camera's light cutting through black. Then, as the lens descended further, the walls came into view. Concrete. Stained. Damp in places, but intact. The camera panned slowly, and then it stopped, because the floor wasn't where it should have been. According to the blueprints, the camera should have reached the floor at 5.1 meters depth, but at 6 meters, it was still descending into open space. At 7 meters, the cable slackened. The camera had reached something, but it wasn't the original floor. The image on the monitor showed a surface, uneven, cracked. It looked like a secondary floor, formed from collapsed material. And beneath it, in the narrow gaps between broken slabs, there was movement. Not living movement, but airflow. Dust swirling slowly in convection currents. One of the engineers leaned closer. "There's a draft," he said quietly. "From where?" another asked. No one answered, because sealed vaults don't have drafts. They pulled the camera up and recalibrated the sensors. Then they lowered it again, this time with an air quality monitor attached. The readings came back within seconds. Oxygen, 19.1%. Carbon dioxide, elevated but not dangerous. Humidity, 92%. And something else. A faint but measurable concentration of methane. Methane doesn't appear in sealed concrete vaults. Not unless something is producing it. Or something below is leaking. The crew widened the borehole to 12 centimeters. Wider access, more data. They needed to understand what was happening inside. As the drill cut deeper, the pressure differential became more obvious. Every few minutes, a pulse of cold air would rise from the hole, strong enough to flutter the edges of the plastic sheeting laid around the site. A structural engineer was brought in. She reviewed the scans, the camera footage, the air samples. Then she asked a question no one had considered. Was there any seismic activity in this region over the last 40 years? There had been. A minor quake in 1991, magnitude 3.2, barely noticed above ground. But underground in a sealed chamber, even small shifts can have consequences. The hypothesis began to form. The vault's floor had fractured during the quake, not catastrophically, just enough to create a fissure. Over decades, water seeped in from below, slowly, incrementally, pooling in the lowest points, eroding the concrete from underneath, creating a secondary void. But that didn't explain the airflow, or the methane, or the temperature drop. They lowered the camera again, angling it toward the edges of the collapsed floor. In the southwest corner, there was a gap. Narrow, maybe 30 centimeters wide. The camera's light couldn't reach the bottom, but the airflow was coming from there. A steady, cold draft rising from somewhere deeper. They attached an extendable probe to the camera rig and pushed it through the gap. The feed went dark for a moment as the lens adjusted. Then the image resolved. Another chamber. Smaller, rougher, not man-made. The walls were stone. Natural bedrock. The floor was uneven, covered in a thin layer of standing water, and in the center of the space, there was a fissure in the rock itself. A crack, roughly a meter long, splitting the floor. The airflow was coming from it. They measured the air temperature at the fissure, 8.3 degrees Celsius, 3 degrees colder than the vault above. The draft was steady, consistent. Something below was equalizing pressure, drawing air down into the earth. One of the researchers made a note in his tablet. "This isn't a sealed vault anymore," he said. "It's connected to something." They ran a sonar pulse down through the fissure. The return signal took 4.2 seconds. That suggested depth, a lot of it. At least 100 meters, possibly more. The methane readings spiked near the fissure. Not dangerous levels, but present. Methane occurs naturally in deep earth, produced by the breakdown of organic material or geological processes. But its presence here meant the vault was now part of a much larger system. An aquifer, maybe, or a collapsed mining tunnel from an older era, or something else entirely. They debated whether to continue. Widening the breach further would destabilize the concrete cap, but leaving it as is meant abandoning the investigation. The project lead made the call. "We go deeper, but carefully." Over the next 3 days, they expanded the borehole and reinforced the surrounding concrete. Then they lowered a more advanced probe, a remote crawler equipped with LiDAR, thermal imaging, and multi-spectrum cameras. It descended into the secondary chamber, crossed the uneven floor, and reached the fissure. The LiDAR mapped the space below, a network of narrow cavities branching downward. Natural voids formed by water erosion over centuries. Some passages were too tight for any equipment. Others opened into larger pockets. And in one of those pockets, 60 meters below the vault, the thermal camera detected something unusual. A heat signature, faint, organic, not human, not animal, microbial. What they found wasn't empty space. It was an ecosystem, microscopic, ancient, isolated. Sealed underground environments can develop their own biological systems over time. When a structure is cut off from the surface, the conditions inside begin to shift. Oxygen depletes slowly, carbon dioxide accumulates, moisture condenses, and if there's any organic material present, wood, paper, fabric, even residual bacteria, it begins to break down. In this case, the vault had been sealed with trace organic contaminants, dust particles, skin cells, fabric fibers. Over 40 years, those materials decayed. Microbes adapted to the low oxygen, high humidity environment. They metabolized slowly, producing trace amounts of methane and carbon dioxide. And when the floor fractured, connecting the vault to the natural voids below, those microbes spread. The ecosystem wasn't thriving, but it was stable, existing in the dark, feeding on mineral traces and decaying concrete. The airflow through the fissure kept the system oxygenated just enough to prevent total stagnation. The temperature gradient created convection currents, circulating air and moisture. It wasn't life as we typically imagine it, but it was life. Adapted, patient, waiting in the dark. The researchers sealed the borehole. The metro expansion was rerouted. The site was marked for long-term monitoring, but the questions remained. How many other sealed vaults exist beneath our cities? How many have fractured? How many are no longer isolated? Underground spaces don't stay static. They shift, they crack, they breathe. And sometimes, when we drill down into them, we find they were never truly empty, just waiting.